Hello everyone, so welcome to my channel. So in this videos, I will talk about how we can use the double integral to help us find the probability of the joint probability distribution. So previous we already talked about what is a joint probability distribution. So the main idea is instead of only one random variable, here we have two random variables and we have a PDE, the probability density function of two random variables. Then the probability of these two random variables, we can use this PDE to help us find the probability. So here, let me use this example to explain how we can use the double integral to compute this problem. So in this question, we have two random variables. They are x and y, and we also have a region of this random variable. So here we have our x and y is between 0 and 4, and also we have x should always smaller than our y. And the next thing is in this question we have the PDE here. So this is a function denoted by small f sub xy. And here we have this is a c times principal x plus y. So here for this one, of course, before we use the definition of the probability for two random variables, the first thing is we should find the value of this constant c. So to find this one, what should we use? We should use the property of our joint probability density function. So this is if we integral this f with respect to xy, we will have this equation is equal 1. So this is a property we should use to find the value of our c. And then for here, let me write down this first part. So to find this constant c, the first thing is we need to plug in here our f sub xy, this function, into our equation. And also the other thing is because for our region we have this x and y, we have this should be between 0 and 4 and also x smaller than y. So that means for this upper and lower limited, our double integral, we need to decide the value of this upper and lower limited. So to do this, what should we do? In general, I always draw a graph about this region and then use this one to help us find the upper and lower limited. So here we draw our x-axis and y-axis. And to get the region, the first thing we should have is we know x and y should be between 0 and 4. So here in this case, so let me denote the 4 is, for example, here. So here is our 4 for the x-axis, and then here is 4 for our y-axis. And we know our region should inside this region. So it should be below this 0 to 4, right, like this. And then the next thing is, except this x and y between 0 and 4, we also have another part. This is our x should smaller than y. So in other words, what this means? This means we will have our, if we have an equation x equal y, then after we draw this equation, so I draw this line as the red line here. So this line is our x equal y. And for this question, what they want our x should smaller than y. So we should think about, is this below this line here or is upper this line? So here, for example, what we can do is we just select one point below this line. So for example, the point here, this one. So if we see, look at, for example, let me select some line which is away from our red line, but it's also below this red line. So if for this one, we can find for the x-axis, this will be a number like between 3 to 4. However, if we look at the y-axis, this should be a number between 0 and 1. So this means our x, a number larger than 3, is greater than the y, which is between 0 and 1. So this means for the region under our line, this is something we don't like. We don't like x is too large. So in other words, what we want in this question is a part above our red line. And also still it should be make sure our x and y is between 0 and 4. So that's why in this question what we need is the shadow part. By right, shadow part is a region we want. And the next thing is if we want to decide the upper and lower limited. So the first thing is we need to decide the order of our integral. So here, this one, what I choose the first integral with respect to x and then y. So for this one, then the upper and lower limited for the inner part, this should be something about upper and lower limited for our x. So what we should do is, in this case, we should draw a line on our graph parallel to our x-axis, because now we want to find the upper and lower limited for x. So we draw a line parallel to x-axis. And for this line, what we should do is we should also use this line to cross like parallel to x-axis, and this is also from the smaller part to the larger one. So because the region for our the direction for our x-axis is to right? So for this parallel line is also to right. And then what we need to do is we just look at the intersection of this blue line with our shadow part. So the first intersection is here. So for this one, what they will first touch this one. You can say this is our y-axis, or in other words, it's also this means our value of x is 0. And then the second part they will intersection is the other boundary of our shadow part. So this is our line x equal y. So what this means? This means the left endpoint or intersection is x equals 0, and the right intersection is x equals y. So we will have this is 0 as lower limited and y as upper limited. So this is how we can decide the lower and upper limited for the inner part. And then for the outside part, what is the outside part? The outside part, the lower and upper limited, is a little different. So please remember, for the outside integral, it should always be a number. So if this is double integral about x, y, and we have y as outer integral, then this upper and lower limited is always a number. And what is the number? The lower limited is a minimum of our y, and the upper limited is a maximum of our y. And then if we look at our original region here, so we can find in this part what we have this equation. And then what the lower limited, we can think about this as 0 or maybe x. But I said we need to choose a number. So here what we have 0 as a lower limited for our y. And then for the upper limited, the largest, the maximum, this will be a number, so of course is 4. So this is how we can use the double integral, or how we can find the upper and the lower limited of our double integral. And after we find this one, the next is just solve this integral. So it will similar of our previous double integral. So we just need to treat this as two parts, and when we integral with respect to x, we just treat y as a constant. So for this question, I skip the calculation here. So if you're interested in how to compute this one, just leave me a comment and maybe I will add this later. But the final answer of this part is 32c. And because in the previous we already say this 32c should equal 1. So in other words, we will have c is equal 1 over 32. So this is our value of c. And then the next part for this question is, what is the probability of x smaller than 2 and y smaller than 3? So the idea of this one is we should use this definition of our probability. So here, this one I already write this as a double integral, but we can also write this as a more general case. So for here, this one is if the probability of xy in a region R, then what we can do is we just use the double integral with respect to x and y inside this region, and integral this of our joint probability density function. So in this question, in fact, the definition is very straightforward. The most difficult part is still how we can compute this double integral and how we can find the upper and the lower limit for this one. The first step is to solve this one. The first step is still draw a graph and find the upper and the lower limit. So here, let me draw the graph again. So this graph is our original region for our x and y, right? So this is our 0 smaller than x, smaller than y, smaller than 4. So for this question, what we need is the original region is same. It's still this shadow part above our line x equal 1. But in this question, we have two more requirements. So what is two more requirements? For this question, what we want is a probability x is smaller than 2 and y is smaller than 3. So what we have is, in our original question, we should draw this two part into our graph. So one is x equal 2 and the other is y equal 3. So let me draw this two line in red into our graph. So here in this graph, I already add this two line. One is for x equal 2 and the other is y equal 3. And for this question, what they want us to have x smaller than 2, right? So if x smaller than 2, so what this means? This means what we want is the left part of this vertical line, the left part of x equal 2. And then for the y smaller than 3, what we want the lower part of our vertical horizon red line for the y equals 3. So if we need to find the intersection between the left part of our x equal 2, the lower part of our y equals 3, and also the green shadow part of our original region. So if we look at this, what we will have? So we will have a part here. I use this as a red, maybe I use another color for this one. So here I use this yellow one to highlight this part. So this is a region we want for this probability. And then the next thing is, now we already finished draw this graph. We already find the region we want. The next thing is similar, is we need to find the upper and the lower limit. So for our question, what we have is, our question is again about integral with respect to x and y. So now the question is, we decide to integral first with respect to x or first with respect to y. So of course this is no problem. We just need to find one of it. So here what I choose is, again, I will choose with respect to x first. So in this question, because I choose to integral with respect to x first, so what we need is we need again to draw a parallel line with respect to x. So here, if we draw a line parallel to x, again we can find if I put this line here, for example this one, so the first thing they will touch is again the y-axis. So this means this is x equals 0. And then the next line they will touch is the right endpoint or intersection is x equal y for here. However, if I draw this line a little upper side, so with this one, for the left hand side, this intersection is still x equals 0, but the right endpoint, instead of this green line, the x equal y, now the right intersection is our right vertical line, this x equal 2. So what this means? This means what we will have is if we have this parallel line with respect to x-axis in different location, we will have different upper and lower limits. And what's the key change here? So the key point is this intersection of our right vertical line and this green line, this x equal y. So if this one is in below this endpoint, we have lower limit is 0, upper limit is y. If this x blue line is above this intersection, then we will have lower limited is 0 and upper limited is 2. So in this case, of course, we can consistent on this situation. We can still use this direction. First integral with respect to x and then with respect to y. But what we need, we will has to divide this to two parts. The first part is, as I said, below this intersection, and the second one is above this intersection. And the difference is we need to find the vertical, this value, the value of this point y. It will be a little complicated. So instead of do this, what should we do? We should change the order of our double integral. So here, instead of integral first with respect to x and then with respect to y, what should we do is we should integral first with respect to y and then with respect to x. So in this one, when we change the order of our integral, now if we try to compute this or decide the upper and lower limited, the first thing we should do is we should draw a line parallel to our y-axis. And now you can see no matter we put this purple line here, or we put as a little left, or we put as a little right, it's still the first intersection is our line, this one. So this is x equal y, or in other words, is y equal x. And the second intersection is our horizon red line. So this is our y equals 3. So that means for our upper and lower limited, the lower limited for our y is x, the upper limit for our y is 3. Okay, so this is now is good. We don't need to divide it to two parts. And then the next thing is for our x. So for x, I already say because it's outer integral, it should be some upper and lower limit should be a number. And this is the minimum of our x and maximum of our x. So if we look at this graph, what's the minimum value of our x? So the minimum value here, of course, is this one. So this is x equals 0. And then what is the maximum value of our x is any value here. So So this is means we have this is x equal 2. So this is a minimum and maximum of our integral of our x. So that's why lower is 2 and upper limited is lower limited is 0 and the upper limited is 2. So this is how we can decide the lower and upper limited of this question. And then the next thing is just compute this double integral, right? So it will go back to the calculus knowledge. So if you're interested in that materials, just leave me a comment and I can upload the more detail to this. So now this is the end of this videos, and hopefully you like it. Please subscribe my channel and see you in next video.